For the first time in history, the eyes of Earth and even Mars have captured the full passage of an interstellar traveler in real time. Its name, 3I Atlas, and this is the visual record of its journey. These aren't simulations. These are real images from the Atacama Desert to Mauna Kea, from space observatories to Martian skies. Together, they tell the unfolding story of a cosmic object unlike anything we've ever seen. Let's decode every photograph, every frame of this visitor from beyond our sun. On October 5th, 2025, an image emerged that split the scientific world in two. Captured by NASA's Perseverance rover from the dusty floor of Jezero crater, a faint glowing streak crosses the thin atmosphere above Mars. Could it really be 3I Atlas? The timing was uncanny. The direction matched projected coordinates, but skeptics warned it could be a sensor glitch or the result of stacked exposures. Even cosmic rays can play tricks on digital optics. Still, the image sparked viral debate. If verified, this would mark the first ground-level photo of an interstellar object taken from the surface of another planet. An eerie, beautiful glimpse, possibly of a cosmic drifter seen through Martian dust. And it wouldn't be the only photo taken from Mars. Just 2 days earlier, on October 3rd, the European Space Agency's ExoMars Trace Gas Orbiter locked its instruments onto the sky above the red planet. The result, a tiny silver trail faintly slicing through the Martian night. 3I Atlas, caught from orbit around another world. This wasn't just a scientific achievement. It was a symbol. Humanity now tracks interstellar visitors not just from Earth, but from other planets. Mars had joined the watch. In that brief, subtle image lies a quiet revolution. A Martian spacecraft photographing a foreign object from another star system, passing between two worlds. Back in Earth orbit, the Hubble Space Telescope turned its legendary optics toward 3I Atlas in late July. What it revealed would become the most widely recognized image of the comet to date, a glowing blue halo, stretched like a lantern's flame suspended in the void. This wasn't just a smudge of light, it was a coma, the delicate shroud of gas and dust that forms as sunlight warms a comet's icy core. And Hubble saw it in exquisite detail. For many across the globe, this image transformed 3I Atlas from a scientific discovery into something real, beautiful, and mysterious, a ghostly traveler from the deep galactic dark. Some cameras see light, others see truth hidden in wavelengths invisible to our eyes. Enter the James Webb Space Telescope. In August, it aimed its golden mirrors at 3I Atlas and peeled back layers of mystery using infrared detection. The result wasn't a photograph in the traditional sense, but rather a molecular fingerprint. Webb found unmistakable traces of frozen water, carbon dioxide, carbon monoxide, sulfur compounds, and even rare organic molecules, ingredients that could only have formed in a cold, distant stellar nursery. It all began in the quiet darkness of July 2025, atop a mountain in northern Chile. The Atlas Survey Telescope, funded by NASA and designed to spot hazardous asteroids, detected a moving speck of light that didn't belong. It was fast, too fast, and its trajectory, hyperbolic, coming from beyond the sun's gravity. These grainy, static-filled images might look unimpressive, a dot here, a faint streak there, but these were the very first photos, humanity's first glimpse of 3I Atlas. To the untrained eye, just pixels. But to astronomers, these were the footprints of something extraordinary. By late August, the silent traveler that had once been no more than a faint moving dot began to transform before our very eyes. High in the Chilean Andes, the Gemini South Telescope, one of the most advanced optical observatories on Earth, turned its 8-meter mirror toward 3I Atlas. What it saw was breathtaking. After weeks of quiet motion, the interstellar object had developed a glowing, fully formed tail that stretched across the field of view like a cosmic banner. Astronomers use multiband optical filters to peel away the interference of distant stars, revealing the comet in pure color. What emerged was a sweeping arc of dust and gas, golden near the core, fading to electric blue along the edges. These hues weren't artistic touches, they were clues. The gold signaled sodium and silicate dust. The blue marked ionized carbon and oxygen, reacting under the sun's fierce radiation. For the first time, 3I Atlas looked familiar, a classic comet with a head, coma, and luminous tail. Yet something about it still felt alien. The way its tail flickered, its density gradients, its strange oscillations, none quite matched known solar system comets. The tail seemed to pulse, suggesting jets erupting from deep beneath its crust, driven by compounds not yet cataloged. These Gemini South images became iconic, not only for their beauty, but because they marked the exact moment an interstellar stranger began behaving like a native of our solar system. The visitor had adapted to our sun, responding to its warmth, and for a fleeting instant, it looked like one of us. Between August 7th and 15th, NASA's Sphere-X mission, a spacecraft designed to survey the entire sky in infrared, focused on the interstellar visitor. Unlike Hubble or Gemini, Sphere-X doesn't take traditional pictures. Instead, it records spectral fingerprints, turning invisible wavelengths into maps of chemical identity. When scientists decoded the data, they were stunned. The comet's coma was rich in carbon dioxide ice, water vapor, and long carbon chain molecules, compounds essential to organic chemistry. There were even faint traces of carbonyl sulfide, a molecule that on Earth plays a role in prebiotic processes. Each detection came from light absorbed and re-emitted at precise frequencies, a cosmic barcode revealing the comet's inner composition. This wasn't just another ball of ice and dust, it was a time capsule from another star system. These materials were likely forged in a molecular cloud billions of years ago, surviving eons of interstellar travel before entering our sun's domain. Sphere-X's infrared heat maps looked nothing like the colorful visuals from ground telescopes, yet they carried more meaning. They allowed scientists to trace temperature variations within the coma, identify volatile layers peeling off the nucleus, and even estimate the depth of its icy crust. A world away from Chile, another giant mirror turned skyward. Perched 13,000 feet above sea level on Mauna Kea, Hawaii, the Gemini North Telescope was among the first to give 3I Atlas its true colors. In mid-July, astronomers equipped Gemini North with its GMOSN spectrograph, capturing separate exposures through red, green, and blue filters. When combined, the result was a full-color composite, not an artist's rendering, but an authentic glimpse of how the comet might appear to the human eye if we could somehow stand beside it in space. The portrait revealed a delicate iridescent haze enveloping the nucleus, glowing faintly against the deep black backdrop. Hints of cyan and pale amber shimmered across the coma, evidence of volatile gases fluorescing as sunlight struck them. At first glance, the comet seemed peaceful, serene, but beneath that soft halo, powerful forces were at work. Subtle asymmetries in the light profile suggested that one side of the comet was venting more material than the other, an indication of rotational jets firing intermittently, sculpting its evolving face. By analyzing color variations across pixels, researchers inferred temperature gradients, chemical ratios, and even estimates of grain size within the dust. It wasn't flashy, it wasn't enormous, but this was the first image that gave 3I Atlas a personality, something tangible, something alive. For the public, it was beauty. For scientists, it was data wrapped in light, and together, those hues whispered a quiet truth, that even in the darkness between stars, color finds a way to shine. In the dry, razor-clear air of Chile's Atacama Desert, the Very Large Telescope, VLT, joined the campaign to study 3I Atlas up close. Its array of 4 giant mirrors, each spanning 8 meters, made it one of the sharpest eyes on the planet. Using the FORS-2 instrument, astronomers captured a sequence of high-contrast exposures designed to isolate the comet from the crowded star fields of the Milky Way. In the processed images, 3I Atlas appears as a bright, crystalline dot surrounded by a faint, expanding glow, its coma. Every photon of light was carefully analyzed to determine brightness, size, and motion. These weren't glamour shots. They were diagnostic scans. By tracking how the intensity changed from night to night, scientists measured the rate at which the comet's gases were venting into space. The data revealed that its activity was rising faster than models predicted, suggesting internal pockets of volatile material bursting open as it neared the sun. The VLT's precision also uncovered subtle deviations in its trajectory, Tiny changes likely caused by outgassing thrust, meaning the comet might be slightly maneuvering as it released vapor. This was an astonishing realization. 3I Atlas wasn't just moving through space, it was interacting with it. To the naked eye, the frames might look minimal, but to astronomers, they represented a heartbeat chart of a living, changing object. Through VLT's lens, 3I Atlas was no longer a mystery drifting aimlessly. It was an active participant in the cosmic ballet, responding, reacting, and transforming beneath the heat of our star. In just a matter of months, we've gone from a pixel on a screen to a cosmic portrait gallery. We've seen real photos of 3I Atlas, from Earth's most powerful telescopes, to spacecraft orbiting Mars, to possibly even a shot taken from Martian soil itself. Where does 3I Atlas headed next? No one knows for sure. But one thing's certain, this story is not over. And the next time a traveler from another star enters our skies, we'll be watching. If this journey through real cosmic imagery gave you chills, hit subscribe, drop a comment with your favorite photo, and stay tuned, because 3I Atlas is still revealing secrets with every passing day. Until next time, keep watching the skies and stay curious.